Good morning, everyone. Thank you for joining us today. Last time, we really got into the minds of modern automation, diving deep into the AI and machine learning that creates that spark of intelligence. Well, today, we're giving those minds a body. We are talking about a totally revolutionary class of machine that's stepping out of the steel cage and right onto the factory floor to work beside us. I'm talking about collaborative robots, or as we call them, Cobots. So let's dive in and see how this new coworker is fundamentally reshaping the future of work.
So, how are we going to unpack this whole revolution? Well, we'll start with a tale of two robots, really contrasting the old guard with the new. Then we're going to explore the incredible synergy that's created when you mesh human creativity with machine precision. After that, we'll get into the nitty-gritty of the technology and the standards that actually make this partnership safe. Then we get to the fun part, seeing these cobots in action with some absolutely fascinating real-world examples. And finally, we'll zoom out to really understand what this new era of partnership means for all of us.
So what's the big deal about cobots, really? To get what makes them so revolutionary, we first have to look at the machines they were designed to improve upon. And that leads us right to our first core question. What is the fundamental difference in the design philosophy between a traditional industrial robot and a cobot?
This slide just captures it perfectly. Two totally opposing philosophies. On one side, you've got the traditional industrial robot. Think of it like a caged beast, a heavyweight champion built for one thing and one thing only, raw power and blistering speed, but only in a perfectly predictable world. Its whole reason for being is maximum throughput, and it lives behind steel bars for a very, very good reason. It's completely oblivious to its surroundings. And then on the other side, we have the cobot. It's an adaptable partner, intelligently designed for our messy, unpredictable human world. Its design priorities are completely flipped. Safety, flexibility, and collaboration come first. It's not about separation, it's all about partnership.
Now, this leap from a caged beast to a collaborative partner, that's not just some marketing slogan. It's enabled by a really specific, groundbreaking set of technologies. This brings us to a critical question. What is the single most important safety feature that allows a cobot to work right next to a person without a cage?
The key is something called power and force limiting, or PFL. This is the technology that basically breaks the chains. Imagine this. Inside every single joint of the cobot, you have these incredibly high-resolution sensors constantly monitoring the electrical current and the forces being applied thousands of times a second. So if the arm bumps into something it's not expecting, say your shoulder or a misplaced tool, that creates this tiny, instantaneous spike in the motor current. The controller sees this anomaly in milliseconds, literally faster than you can react, and just slams on the brakes. The really critical part is that it stops before it can build up enough force to actually cause harm. This built-in sense of touch is what separates it from a traditional robot that would just plow through anything in its way with terrifying force.
Okay, so we've established that cobots are engineered from the ground up to be safe around people. But why does that matter so much? Well, this brings us to our second section, the incredible synergy you get when you pair human ingenuity with robotic precision. This isn't about replacing people. It's about making them almost superhuman at their jobs.
You know, a huge part of this synergy is just accessibility. For decades, programming a robot was like a dark art, right? You needed a specialized engineer writing pages of complex proprietary code. It created this enormous barrier. So how have cobots completely shattered this and, in a very real sense, democratized the entire field of robotics?
This right here illustrates the revolution in usability. Instead of writing lines of code, you just use your own hands. An operator on the factory floor can press a button on the cobot's wrist, which puts it into this zero-gravity teach mode. And in this state, the motors just counteract gravity, making this incredibly sophisticated machine feel almost weightless. The operator can then physically grab the arm and guide it through the exact path they want it to follow. Then, using a simple graphical interface on a tablet, something anyone who's used a smartphone can figure out, they can fine-tune those points and add logic like open the gripper or wait for a signal. The impact of this is just staggering. A skilled technician can now deploy a robot for a brand new task in a matter of hours, not weeks, all without needing an engineering degree. And this incredible accessibility really gets to the very heart of the cobot's value. The narrative we so often hear about automation is one of fear, right? Of replacement. But cobots are explicitly designed for augmentation. They're tools, just like a power drill or a calculator, designed to enhance our human capabilities. They take over the parts of a job that humans are just not well suited for, and that frees us up to focus on the things we do best: thinking, creating, and solving problems.
We can break this down into the 3 Ds: dull, dirty, and dangerous. Take machine tending, a classic dull task.
A skilled machinist's expertise is in their brain. It's in quality control and complex setups, not their back. But so much of their day can be spent just on the mind-numbing repetition of loading a part, waiting, and then unloading it. A cobot can do that 24/7 without a single complaint. This frees up that machinist to oversee multiple machines, focus on higher-value work, and actually use their skills. This doesn't just skyrocket productivity, it dramatically improves job satisfaction and cuts down on the risk of repetitive strain injuries.
Let's look at how this builds the perfect partnership. This table lays it out so clearly. Humans, we bring adaptability, creativity, and incredible dexterity. We can improvise, we can react to the unexpected. The cobot, on the other hand, brings tireless endurance, microscopic precision, and flawless consistency. It can repeat a task thousands of times without the slightest variation or getting tired. So when you combine these complementary strengths, you get a system that's way more powerful, flexible, and efficient than either a human or a robot could ever be on their own.
Now, this powerful partnership, this ability to work shoulder to shoulder, isn't just based on some clever design. It's built on a bedrock of rigorous engineering and internationally recognized safety standards. This brings us to our third section, how we actually engineer the trust that makes this close collaboration not just possible, but safe. The bedrock of cobot safety is a technical specification called ISO/TS 1566. Think of it as the constitution for collaborative robotics. It's not just a guideline. It lays out the detailed technical rules for assessing risks and implementing safety features for any collaborative application. This document is crucial because it ensures that safety is a matter of rigorous engineering, not just wishful thinking.
So let's explore this a bit. ISO/TS 150660 basically gives engineers a toolbox with 4 distinct safety strategies. These can be used by themselves or combined to create this multi-layered safety system. First up is the safety monitored stop. Here, the robot can work at full speed, but sensors, like a light curtain or a laser scanner, create a virtual fence. The moment a person crosses it, the robot stops instantly. It holds its position until the person leaves, and then it automatically gets back to work. Simple, effective. Second is hand guiding, which we've already seen. That's the mode that lets an operator safely enter the workspace and physically move the robot by hand. Third, we have speed and separation monitoring. This one's way more dynamic. A laser scanner acts like a kind of radar, continuously tracking the distance between the person and the robot. The closer the person gets, the slower the robot moves. If they get too close, it stops completely. And finally, we have power and force limiting, the most sophisticated mode we talked about earlier. This is the only one that allows for potential physical contact because the robot is intrinsically designed to be safe.
This leads us to an absolutely critical question that trips a lot of people up. We know a PFL-rated cobot is designed to be safe on its own, but does that mean any application using that cobot is automatically safe for human contact? The answer is absolutely not. And this gets to a fundamental principle of industrial safety. You must look at the whole system. The cobot arm itself might be perfectly safe to bump into, but what if it's holding a soldering iron at 400 degrees Celsius or a spinning blade? That tool at the end of the arm, what we call the end effector, completely changes the safety equation. A thorough risk assessment has to always consider the robot, the tool, and the task to make sure that the promise of collaboration is delivered safely.
All right, so we've covered the philosophy, the synergy, and the safety standards. Now let's get to the really exciting part and look at how these concepts are being applied in the real world. This is where the theory becomes reality, and we can see the tangible impact this tech is having across some incredibly diverse industries.
When you talk about cobots, you pretty much have to start with Universal Robots. This Danish company practically invented the modern cobot. Their lightweight, super user-friendly arms democratized automation, making it affordable and accessible for small and medium-sized businesses for the very first time. A small machine shop could suddenly have a robot on a cart tending a CNC lathe in the morning and then helping with product assembly in the afternoon. This robot on wheels concept was a complete game changer for businesses that needed that kind of flexibility to survive.
Now let's jump from the machine shop to a totally different world, the operating room. The Vinci surgical system is maybe the ultimate human-robot team. The surgeon isn't replaced, they're empowered. From a sophisticated console, their hand movements are translated in real time to the robot's tiny instruments with unbelievable precision. The robot completely filters out natural hand tremors, it can scale large hand movements down into sub-millimeter micro-movements, and its wrists can move in ways a human wrist simply can't. The surgeon brings the brilliant mind, the cobot brings the superhuman dexterity.
And now for the massive world of logistics. In a modern e-commerce warehouse, a worker can walk for miles and miles every single day. Mobile cobots from companies like Robotics completely flip this inefficient script. The human worker stays in one zone, and the robots autonomously come to them, showing on a screen exactly what to pick. The human does what they do best, quickly and dexterously grabbing an item, and the robot does all the legwork. This simple but brilliant partnership is a massive win for both warehouse efficiency and for worker well-being.
These powerful examples bring us to our final section. We've seen the technology, the synergy, and the real-world applications, so now let's zoom out and consider the overarching thesis. What does the rise of the cobot really tell us about the future of automation and our place within it?
Posing this as our final question really helps to focus the conclusion. After everything we've talked about, from design philosophy to safety standards to surgical robots, what is the single most important insight we should take away as we look towards an increasingly automated future?
This quote just says it all. The rise of the cobot isn't just a new piece of technology, it's a fundamental paradigm shift. We are moving away from a world of rigid separation, humans on one side of the fence, robots on the other, and we're moving toward a future of fluid, dynamic collaboration. The key takeaway is this: the future isn't humans versus robots, it's humans with robots, working together to achieve more than either could ever accomplish alone.
So let's wrap it all up with the key takeaways. First, cobots are a whole new breed of robot, born from a philosophy of safety and collaboration, not isolation and power. Second, they're here to augment our skills, not replace us, by taking on the jobs that are dull, dirty, and dangerous, which makes our work lives better. Third, this incredible partnership is built on a foundation of trust that's engineered through rigorous safety standards like ISO/TS 15066. And finally, all of this points to a future that's going to be defined by a powerful human-robot partnership. This new coworker is here to stay, and believe me, this is just the beginning. Be sure to tune in for our next deep dive, Automation Unleashed, from smart farms to robotic surgeons, where we'll explore even more advanced applications of these collaborative principles. Thank you for joining us, and don't forget to subscribe to our channel, Tech, AI, and Beyond.